Mice pie. Mice never tasted so delicious.
To introduce the so-called binomial distribution. All right, binomial distribution. So what is the binomial distribution? Be careful here. All right, be careful here. So we're considering an experiment consisting of n independent Bernoulli trials with a constant probability of success. Basically, it's a Bernoulli process of length n. Independent Bernoulli trials with exactly the same probability of success p. All right, here n is fixed. It's the number of probability trials, Bernoulli trials. Like you flip this coin for 10 times, right? You just flip this one for 10 times. The unindependent flipping of the coins, right? So this is our experiment of a fair coin. And then what? The total number of successes. All right, so we're interested in the total number of successes. Okay, X is called a Bernoulli random variable, a binomial random variable. Okay, here the parameters is n and p, denoted by this. Again, if you consider this flipping the coin for 10 times, all right, say the head, let's denote head as success, all right, tail as a failure. Okay, so among these 10 times of flipping the coin, okay, how many of them are successes or means heads? How many heads among them? Right? So we're interested in this number. This number of heads we get from these 10 times of flipping of the coin is what? A Bernoulli random variable. Now here we have the parameters, and n is going to be 10 because we have 10 Bernoulli trial, 10 flipping the coins. And that's the total number of the coin flippings. P here, because it's a fair coin, we have this constant probability of success as 1/2. So in that case, we will have what? So-called B of 10.5 in that case, right? So that means it has a Bernoulli, a binomial distribution with parameters n equals 10, p equals 0.5. All right, so here, be careful. X is what? X is the number of successes. All right, number of heads among these 10 trials, right? So that's the number of successes. Well, this is a very abstract concept, all right? But it can be generalized, but not generalized. It can be applied in many different situations. All right, so I'm going to just give you an example. All right, like our attendance checking, like our attendance checking today, right? So I'm just every time, let's just assume, all right, is I do under the assumption that the chance that every student, all right, randomly select one, all right, our class is going to be independent, and also you guys share the same probability of attending the class. So every time I'm calling out the name, I'm conducting a Bernoulli trial, right? You may say here, or you may do not respond. If you do not respond, I will say that's a failure. But if you responded, that's going to be a success, right? So every class before we do the lecture, so I check the attendance. Then I'm going to take what? Like in our class, we have 37 or 35, 37 students. So I'm conducting 37 Bernoulli trials, right? Bernoulli trials, and in every class, right? So then, how many are here? How many responded? Right? This number of students in your class who responded is going to be a binomial random variable. It's going to be a binomial under the condition, of course, under the condition that they're independent and they share the same probability of success. Of course, this is in many cases untrue, not true. All right, but under this assumption, it's going to be a binomial random variable. Okay, so we have the following. All right, then given the this binomial random variable, the PMF of x. All right, the PMF of x is given by the following. All right, P of x equals x. Okay, so here this is the formula. Okay, anyway, this I need to change this one. N minus x. All right, so here x equals 0, 1, 2, n. Okay, so we need to be careful. All right, the possible values of success. All right, the possible values of x, a number of successes among these n independent trials. It may be what? It may be 0. There's no success, all failed, all right, all failures. Or 1, there are 1 success. All the others are failures, right? Or 0, 1, 2, till what? N. N is all of these trials resulted in a success. So the possible values of this Bernoulli random variable are 0, 1, 2, n. 0, 1, 2, till n. Okay, so that's the possible values of x. Now, for each x, all right, for each x among these 0 to n, we have the corresponding probability values. All right, P of x equals x. This is n choose x. Anybody remember what this is? N choose x. That's the number of what? Number of combinations. All right, number of combinations. If we select of n objects chosen x at a time, all right, without recording the order. Order doesn't matter, right? The number of combination. It is what? N choose x is n factorial over x factorial times n minus x factorial. Okay, so you can also use the calculator to find this number. All right, as we did in Texas Texas TI-83 and 84. All right, we did that before. Now here, the next is p to the power x. Now here, p is the probability of success. You have x successes, so p to the power x. 1 minus p, okay, here is n minus x. All right, sorry, it is the power is n minus x. All right, so this is a probability of the failure. You have n minus 1 failures, so 1 minus p raised to power n minus x. Okay, and the expectation is np and the variance is np 1 minus p. All right, so these are all the information about the binomial distribution with parameter n and p. All right, so we have the PMF, we have the expectation, and also we have the variance. And of course, we can get the standard deviation as well. Take the square root of this variance. Okay, now consider this example. All right, consider this example. Okay, find, all right, so the probability that x equals 3. All right, x equals 3. Now, here I'm going to firstly work with you with the using the formulas. All right, so let's do this one. Now here n equals what? 8, p equals 0.5. All right, so that's like the flipping the coin for 8 times. All right, a fair coin. Now x is the number of heads. All right, number of heads. So what is the probability that we got 3 heads? Px equals 3. So what is the x equals 3? So we have what? By definition, we know that it is n choose x, right? So we want to see n is 8. 8 choose 3. Okay, 8 choose 3. All right. So times p is 0.5. Raised to power what? Raised to power 3. P to the power x, 1 minus 5 raised to power what? 8 minus 3. Okay, so this is the probability for x equals 3 because by definition, by this formula of PMF, we got the probability x equals x is n choose x, p to the power x, 1 minus p to the power n minus x. Make sense? All right, so this equals what? Okay, so we can use the calculator to find 8 choose 3. Remember how to do that? It is math. So firstly you need to input 8. Okay, 8 and math. Okay, so let me just do this one here. All right, remind you using the calculator nx. You choose n and go to math and go to I believe is PRB. Okay, so and then go PRB and then go to what? Go to 3 n choose r. Go to 3 and choose r and then get x and then enter. All right, this is based on TI-8384. All right, TI-8384. Okay, so now if we want to find 8 choose 3, what is 8 choose 3? 56. All right, exactly. All right, this is going to be 56 times 0.5 raised to power 3 times here 1 minus 0.5 is again 0.5 raised to power what? 5. Okay, so let's just calculate this one together. So 56 times 0.5 raised to power 3 and times 0.5 raised to power 5. Yes, we got what? 0.21875. Okay, 21875. Very good. Okay, so if you want to run to 3 decimal places, that's fine. But if you want to leave it this as this, that's also okay for this question. All right, so let's just leave it as it is, all right? So this is the probability of x equals 3. So we basically did this one using the formula, right? Using the formula. Now, how about 2? The probability for x is less or equal than 3. Now, how do we calculate this one? Less or equal than 3. So that means what? The number of successes is less or equal than 3. So the possible values, the x less or equal than 3, then x can be what?
Is that going to be the summation of like x equals 3, x equals 2, x equals 1, and x equals 0?
Exactly. Okay, very good. All right. Here, x less or equal than 3 is going to be what? Because it must be what? The possible values of x is 0, 1, 2, till n. In this case, is 0, 1, 2, 3, till 8. Right? That's the possible values of x. But here we're talking about x less or equal than 3. So it became what? X equal to 0. Right? Number of successes can be 0, right? Or 1, or 2, or 3. Or less or equal than 3. Be careful. 3 is included. All right, 3 is included. So it equals the probability of x equals 0 plus probability x equals 1 plus probability x equals 2 plus probability x equals 3. Okay, so what is this probability? All right, so of course we can find these values, right? We can find these values. All right, so what is the probability for x equals 0? Okay, we can plug in 8, choose 0, 0.5 raised to power 0 times 1 minus 0.5 raised to power 8 minus 0. All right, so basically this is the first term plus Emily asked the question, how do you all put that 8 into the calculator again? Okay, very good, Emily. That's not 8 over 3. All right, that's 8 choose 3. Okay, this is the number of combinations we have. Okay, so firstly, this is based on TI-83 or 84. Okay, so this is I only give instructions based on this calculator. But if you have other calculators, you can you can simply Google it. All right, it should be fine. Okay, so you firstly input 8, and then go to math, and then go to PRB, and then go NCR, and then you input 3, and then enter. Okay, so then you should be able to get this answer. Emily, let me know if you got it. All right, you're welcome. Very good. Okay, so this is how we got the first term. Similarly, we can get the second term, 8 choose 1, 0.5 raised to power 1, 1 minus 0.5, 8 minus 1. All right, so 8 choose 2, 0.5 raised to power 2, 1 minus 0.5 raised to power 8 minus 2. Okay, plus 8 choose 3, 0.5 raised to power 3, 1 minus 0.5 raised to power 8 minus 3. Okay, so 8 minus 3. Okay, basically this is exactly what we get in 1, right? So, and you can calculate this number. All right, anybody got the first? Well, what I get is 0.5 raised to power 8. Okay, I'm going to just write in this way, all right? So plus, all right, it's 8 times 0.5 raised to power 8. Now plus, okay, 8 choose 2. What is 8 choose 2? 28, is that right? 28 times 0.5 square to the power 8. And lastly, that's 56 times 0.5 raised to power 8. Okay, so this equals what? Let's just do this one all together. We found that they have a common term, 0.5 to the power 8, right? So that's going to be 1 plus 8 plus 28 plus 56 times 0.5 raised to power 8. Okay, 93. Okay, that's 93 times 0.5 raised to power 8. Okay, times 0.5 raised to power 8. Yeah, I got different one. Okay. What I got is 0.363, 0.36. Okay.
Do they all have the common term, 0.5 to the power of 8? Because I thought that's gonna decrease each time. So it should be, the first one will be 0.5 to the power of 8, then it'll be 0.5 to the power of 7 to the power of 6.
But you see that there is a 0.5 to power 1 here. So this is
gotcha.
0.5 to power 8, power 7, that's 0.5 to power 8, right? So this is 0.5 to power 2, here is 0.5 to power 6, that's 0.5 to power 8.
Okay.
Okay.
I might have just put things in the calculator wrong then.
Okay. Okay, anybody else got this answer? Fahad, okay, good. 366, 363. All right, it should be this one. Okay. All right. Well, you see that this is a really long calculation if we do it in this way, right? If we do it in this way. Now for the binomial distributions. Okay. But in this calculator, all right, actually this one can be simply obtained using the calculator. Okay, so now here we are using the formula, right? We can use the formula to find these these values 1 and 2, right? Okay, but as we said, okay, it can be in the future, it can be hard, right? Especially we have large n, right? N is not 8, but 18, something like that, right? So in those cases, if we calculate using the formula, it's going to be not an easy task. Okay, so there are a lot of softwares, statistical softwares, and also this calculator can easily give us those answers. Okay, so here I'm going to just tell you the method, or how to use the calculator. Okay, for X binomial distribution, BNP. All right, so here to find, okay, the probability, okay, this is 1. All right, to find the probability X equals X. All right, so what we do is, okay, we are going to use this calculator. So you go to second, excuse me, second, go to district. All right, district is on top of the various vars. Okay, and then in the distributions, you can find this binomial PDF. Binorm PDF, all right? Be careful, it's a PDF, all right? So here in this PDF, you want to input, there is N, all right? And P, and then paste whatever the value of this X is. Okay, in this one. Some of us have a different, based on different settings, you will have different arguments, but what do you want to, the first is the number of trials, the second is the probability of success, and the third is the value of interest. All right, what the kind of value you want to get, okay? And then you go to enter. Okay, and you will got maybe enter again. All right, you maybe enter again. You will find this probability for x equals x. Okay, now not in this calculator. All right, we can also find another probability that's called the CDF. All right, f. Remember f of x. What is f of x? That's the probability for x less or equal than x. Okay, so that's to find the value of the CDF. All right, here is capital F of x. Remember, we did that before, right? It's by definition, what's the probability of x less or equal than x? The probability accumulated up to the point x. Okay, so to find this one, we can also use this calculator similarly. Second, go to this tree, go to here. All right, instead of binorm PDF, we have binorm CDF. All right, be careful here. It is a binorm CDF. Again, NPX. All right, and then you enter. Okay, and then you enter. Okay, so of course, this is the two functions or the two quantities that can be found directly using the calculator. All right, using calculator, we can directly find the probability of x equals x or the probability less or equal than x. Now, of course, if we are having other types of probabilities, for instance, x is strictly less than x, or x is greater than x, or something like that. All right, so we need to transform it into one of the above. Okay, for other probabilities, okay, probability such as the probability of x strictly less than x, or probability of x is greater than x, and so on. We transform, we represent them in terms of the probabilities. Okay, 1 second, please. My computer is low. Okay, now it's good. The probability probability of x greater or less or equal than sorry. less or equal to x and probability of x equals x. Okay, so and then use the calculator. All right, so for instance, I just give an example. All right, for instance, now probability of x strictly less than x equals what? You can, if x is an integer, right? So it is x less or equal than x minus the probability of x equals x, right? Or it's simply what? X less or equal than x minus 1. Okay, so basically it's the same. All right, strictly less than x, right? Is less or equal than x minus it equals x. This is true, right? We can use a calculator to find this one and a calculator to find this one and do the minus sign. Or directly we can use the x less than x is simply x less or equal than x minus 1. Here is when what? X is integer. All right, x is a whole number. If x is an integer, then we can do this. All right. Now for binomial distribution, since we are talking about the number of successes, so therefore they are the case. Okay. All right. So we introduced these. All right. The calculator tip for binomial distribution. Now, all right. Let's do this one with this problem again. All right, and see how can we find these probabilities using the calculator instead. All right, using the calculator instead. All right, so for instance, let's do 1. All right, the probability for x equals 3. So using the calculator, let me just write down the final binorm. Binorm here should be PDF or CDF.
PDF.
Yes, very good. All right, be careful. X equals 3. All right, this is PMF or PDF. PDF. Here, the first entry should be what? Should be 8. All right, N. All right, here is N, then followed by P, which is 0.5. All right, and we want to find the probability x equals 3. So then here is 3. Okay, so now if you use a calculator, anybody found the answer, please? Anybody got the answer? Okay, did you got the same answer as what we did before?
Yeah, it worked out for me.
Yeah. Okay, very good. Okay, this is how it works. All right, we can use the calculator to directly find these values. Now, how about the second? Less or equal than x. That's what? Binorm. Binorm here, be careful. It is what? Less or equal than 3. It's a CDF, or a cumulative distribution function. So we use binorm CDF. All right, so 8.5 and 3. Okay, so did you got the, let me just round to 3 decimal places. Did you got this answer? Yes? Okay, very good. Anybody have troubles with this? Okay, of course, this is based on TI-83 or 84. Okay, so if you have other versions of calculators, I believe, all right, majority of the calculator can do the work. You simply have to Google it. All right, you simply have to Google it. I should be able to find this. Okay, or you know, worst way scenario, you can always use the formulas to find these values, right? So that's something we can do. Now following, I'm going to just use the formulas, all right, using the calculator to calculate all these values. Now, how about x greater than 3? C, 3. Probability for x greater than 3. Now, for this one, this is none of the form of the previous two, right? So we cannot use the calculator to directly find this value. However, for this one, we can transform it into an equation. Yes, very good, John. All right. So transform it into a formula, into an expression that in terms of those values. For this one, it's pretty easy. We want to find the probability x is greater than 3. X is greater than 3, so we can use the complement rule of the probability. It is 1 minus the probability of the complement, which means x is less or equal than 3. Right? So, and because then we can use the calculator to find this, right? Which we already found it is 0.363, right? So we can just directly use it. 637. All right. So we got this one. All right. So basically, that's how we do. All right. If it is one of those forms, we can directly use the calculator. Otherwise, we transform it into expression consisting of those those twos. Okay. Now, how about 4? The probability for x is greater or equal than 5. Greater or equal than 5. For this one, how can we do this? All right, this is, we still have to transform it into an expression, right? Into something. But what's going to be this? 1 minus the probability x less or equal than 4. Okay, that's very good. Exactly what we want to do. All right. So because this is x is greater or equal than 5, right? So the complement of that is going to be less or equal than 4, because here the possible values of x is from 0, 1, 2, 3, well, to 8, right? So integers, the number of successes, right? So therefore, the complement of x greater or equal than 5 is x less or equal than 4. So it is 1 minus the probability for x less or equal than 4. All right. So what is that? 1 minus binorm CDF. All right. So here is 8.5 and 4. So what did we get? Binorm CDF is 8.5. X is 4 here, so paste. Okay, so what I found is 1 minus 0.637. That's again, I got 0.363. All right, I got this one. Okay, so we can get this value here. Okay, so Alex asked the interesting question. Could 1 minus the probability x less than 5 also good? Yes. All right. So this is of course as greater or equal than 5. Okay. So it also equals 1 minus what? probability x is strictly less than 5. Right? So this is definitely true. Right? This is definitely true. Right? So 1 minus the probability x strictly less than 5. But in order to use the calculator, this is strictly less than 5 is what? 1 minus the probability x less or equal than 4. Right? So, and then everything will be the same. Does that make sense, Alex? Okay, very good. All right, so that's question 4. All right, that's question 4. Okay, so we can get these values using the calculators as well. Now, how about 5? The probability of x strictly greater than 5. So for this one, all right, strictly greater than 5, you know, this is similar to 3, all right, is what? 1 minus the probability for x less or equal than 5, right? Strictly greater than 5, right? So it's 1 minus probability for x less or equal than 5. Okay, so we can find this one as 1 minus binorm CDF 8.5 and 5. So it's what? What is this? It's 1 minus 0.855. So it's 0.145. Did you get this? That's what I get. If I round to 3 decimal places, all right, I got this one. Okay. If I round to 3 decimal places, I got this. Okay. Anybody can figure out another way to solve this problem? X greater or equal than 5, greater than 5. Is there another way to solve this problem?
We could take the answer from the previous problem and then just add the PDF of x equals 5.
Add or, you know, or is, let's say that we want to use the result for
or
4.
Subtract. Yeah.
Subtract. Yes. Very good. All right. Or we can say the probability of x greater than 5 equals what? The probability for x greater or equal than 5, right? Minus the probability of x equals 5. All right. So then we already got this in 4. That's, well, at this point, you do not want to run it. All right. So you want to keep it. And this is going to be what do we get from 4? But you do not want to run it at this time. All right. So you want to keep it.
Do you want the full answer? From the previous one, it's 363,28125.
363. Could you say that again?
28125.
All right, very good. All right, and then minus what? The probability for x equals 5. That's what we use the PDF here, right? So using the PDF, it's 8.5, and there is a 5 here. All right, be careful. Now here is a PDF. What did you get? That's going to be 0.21875, right? Okay, so you take the difference of 0.36, 28125, and you round it to 3 decimal places, I believe. Okay, I got okay, 0.144 instead. Okay, but this is a rounding error. All right, I think if you do this one more accurately, then it should be good. Okay, then it should be good. Is that right? But you see that there is a subtle difference here, right? But if we do this one, okay, using okay, I believe what I did is 0.5, and here is gonna be 5. Huh. Well, okay, there is a subtle difference here. Okay, but here is going to be just the rounding errors. All right, there's the rounding errors. All right, there's the rounding error. Rounding error. All right, well, but it's very close. All right, but it's very close. Okay, but either way will be fine. All right, either way will be fine. Okay, then 6 and 7. What's the expectation? All right, be careful. The expectation is n times p. Variance is np times 1 minus p. All right, so np equals 8 times 0.4, that's 0.5, that's 4. All right, and finally we can get the variance equals np 1 minus p. It's 8 times 0.5 times 1 minus 0.5. That's 2. Okay. So basically, this is about the binomial distribution. All right, we got all the calculations and the expectation and the variances for a binomial distribution. Okay, a binomial distribution. Okay, so be careful for this question. There's a lot of issues here, right? We need to learn how to calculate the probability about a binomial distribution, right? And then the expectation and the variance. Okay. Now, all right. Let's say, Aaron, could you read for us? Aaron.
Can you hear me?
Yes, I can hear you.
Can you hear me?
Yeah, I do.
Okay. A national study showed that 40% of college students binge drink. Let X be the number of students in a random sample of N equals 10 students who binge drink.
Okay. All right. Thank you. All right. We want to find these probabilities. Okay. So in this one, we have 40% of the college students binge drink. All right. If now we are interested in what? But this X is the number of students in a random sample who binge drink. All right. So this is, implicitly implies a Bernoulli trial. Okay. So if you ask any student, is this student binge drink or not? Right. One answer is binge drink. The other is no. Right. So this is like a Bernoulli trial. And this one, we have a random sample of n equals 10 students. Here is a random sample. All right, random sample means what? They are independent. All right, these students are independent from each other because it's a random sample. And also, they share the same probability of binge drinking. Okay, so here, all right, you firstly have to figure out what kind of distribution X has. right? So from these keywords, all right, it's a random sample of n equals 10 students, all right? So, and then this probability of success is 40%, okay? So it is clear that what? X has a binomial distribution with what? N equals 10, P equals 0.4, okay? So n equals 10, p equals 0.4. Now, let's try to find these probabilities and expectations and standard deviations. Beers, do we have a quiz today? Oh, okay. Well, it's too late. Let's continue with our lecture. All right. Sorry. I know that you want to have a quiz. Anyway, let's continue with our considering the time. All right. So 1. What is the probability for x less or equal than 5? Using the calculator, anybody? So this is binorm, CDF, right? CDF, be careful. 10.4 and 5. Okay, around to 3 decimal places, we got 0.834. Yes. Anybody else got this answer? So what about the x less than 5? Strictly less than 5. Well, I think you can do the following, all right? Just the less or equal than 4, right? It's the same as less or equal than 4. So binorm CDF, 10.4 and 4. So anybody got this? .633. Yes, very good. All right, I got this one as well. Very good. Now, sorry, probability x greater than 8. Okay, what is this? Okay, anybody can find this, please? Well, you have to be careful, right? Greater than 8. That's what? That's equal to 7. Okay, did we got this? I got 0.01, 0.122, 0.012. Sorry. I got it. It's a 7 or 8. It is greater than 8. Oh, it's less or equal than 8. Ah, yes. Very good, John. All right, it is less or equal than, greater than 8 is going to be 1 less or equal than 8, right? So that's very good. All right, be careful. All right, so be careful on this. If we are talking about a greater than 8, all right, it must be less or equal than 8. That's a complement, okay? So you have to be very careful on that. Okay, so in this way, 1 minus, okay, 8. We got 0.002 if you round to 3 decimal places. Very good. All right, so just be careful. All right, when we are doing this, be careful on this. All right, so it's strictly less than or less than or less or equal, then they are they give different answers. All right, so be careful on that. So expectation of x equals what? N times p. That's 4. All right. Variance of x, np 1 minus p. 2.4. And standard deviation is going to be the square root of the variance, square root of 2.4, 0.5, 1.549. Okay, so that's how we got all these values.